Hi everyone. Today we're going to study sum of products expansion. By taking Boolean sums of distinct mean terms, we can build up a Boolean expression with a specified set of values. A Boolean sum of mean terms has the value 1 when exactly one of the mean terms in the sum has the value 1, while having the value 0 for all other combinations of values of the variables. Consequently, given a Boolean function, a Boolean sum of mean terms can be formed that has the value 1 when this Boolean function has the value 1 and has the value 0 when the function has the value 0. The mean terms in the Boolean sum correspond to those combinations of values for which the function has the value 1. The sum of mean terms that represents the function is called the sum of products expansion, or the disjunctive normal form of the Boolean function. Let us see this example 1. Find the sum of products expansion of the function f of xy equals x bar plus y. To solve this, our goal is to convert the function into a sum of products of the variables or its complements using identities. Let us copy our function down here. For our step 1, we're going to show that each of these variables is a product of 1 and itself. So it will be x bar times 1, then plus this y times 1. This idea is coming from identity law that says x times 1 equals x. We have two products now. In our first product, this is x bar times 1. We can see that there is no variable y in the first product. We're going to introduce now a variable y to replace the number 1. Meanwhile, for the second product, y times 1, there is no variable x. We're going to replace the number 1 by an expression equivalent to 1 with a variable x. So we write now, for the first product, the number 1 is now replaced by y plus y bar. For the second product, the number 1 is replaced by x plus x bar. This idea is coming from the unit property that says x plus x bar equals 1. And from here, we're going to distribute this x bar to each of the variables y plus y bar. The same is true with the second product. The y here is to be distributed to x and then to the x bar. So x bar y plus x bar y bar plus xy plus x bar y. We have now 4 products here. Please observe that our first product x bar y is the same with the fourth product x bar y. According to our idempotent property, we can combine this x bar y and x bar y here into itself. So we write here x bar y plus this product we will copy here along with this product. This idea is coming from idempotent law that says x plus x equals x. Now we have 3 products and this is the sum of products. This is our final answer. Example 2. Find the sum of products expansion of the function f of x, y, z equals x plus y, and this quantity is multiplied to z bar. Our goal is to convert the function into a sum of products of the variables or its complements using identities. Let us write this function down here, and then let us multiply the z var to each of the variable inside the grouping symbol. So we have x times z bar plus y times z bar. We followed the distributive law. And from here, we're going to show that each of this product has another factor, which is the number 1. So we have now x z bar times 1 plus y z bar times 1. This is according to identity law, that x times 1 equals x. We have now two products here. In our first product, there is no variable y. In the second product, there is no variable x. That's why, for the first product, we're going to introduce an expression to replace number 1. And the expression contains y variable. So we have the y plus y bar. In the second product, since there is no x variable, we're going to replace this number 1 by an expression with x variable, and that is the x plus x bar. We get this idea from the unit property that says x plus x bar equals 1. And from here, let us multiply this product outside to each term of the grouping symbols. The same is true with the second product. So we have now x, y, z bar plus x, y bar, z bar. For the second product here, it becomes x, y, z bar plus x bar, y, z bar. We have now 4 products. Please observe that the first product and the third product here are the same. So we can rewrite this line by combining this x, y, z bar into itself. So we write now x, y, z bar plus x, y bar, z bar plus x bar, y, z bar. That is according to idempotent law. X plus x equals x. So we have now 3 sums of products here. This is our final answer. I hope you learned something from this video. See you again next time.